Welcome to Cosmic Compass. Together, we embark on journeys across the vast expanse of the universe, exploring planets, moons, and the extraordinary phenomena that connect them all. Today, we turn our eyes to one of the most dramatic and mesmerizing events in the cosmos, eclipses. We've all experienced, or at least seen, an eclipse on Earth. But what if we told you they happen throughout the solar system, each more breathtaking and mysterious than the last? Let's set out on a voyage beyond our world to witness eclipses as they unfold across alien skies. Imagine standing under a bright midday sky when suddenly the world around you begins to darken. The air cools, shadows sharpen, and above the sun itself disappears behind the moon. For a few brief minutes, day turns into night. This breathtaking moment is what we call a total solar eclipse, and it has fascinated humanity for as long as we have looked at the sky. Here on Earth, we are uniquely positioned for this spectacle. By pure coincidence, the moon is both the right size and the right distance from us, that its apparent diameter in the sky matches that of the sun almost perfectly. When the alignment is just right, the sun's blazing disk vanishes, and what remains is its ghostly outer atmosphere, the corona. Normally invisible, the corona stretches hundreds of thousands of kilometers into space, a luminous halo surrounding the moon's dark silhouette. If you look carefully during such an event, you might also glimpse fiery prominences at the sun's edge, massive arcs of plasma suspended by magnetic fields. It's dramatic, it's eerie, and it's unforgettable. But here's a question: is Earth really the only place in the solar system where eclipses occur? Before we journey beyond Earth, let's make sure we understand the basic mechanics. A total eclipse happens when one body passes in front of the sun, hiding it completely. That process is also known as an occultation. If the alignment isn't perfect, the sun may be only partly covered, resulting in a partial eclipse. When the foreground body appears smaller than the sun, a thin ring of sunlight remains, giving us an annular eclipse. There's also the case of a transit, when a small body like Mercury or Venus crosses the sun's face, but covers only a tiny fraction of it. During a solar eclipse, the moon casts two distinct shadows. The Umbra is the central dark core, only about 950 kilometers wide on Earth. Within this zone, the sun is fully blocked. The penumbra is much broader, where only a portion of the sun is hidden, and observers see a partial eclipse. But why don't we get eclipses every month, since the moon orbits Earth every 27 days? The answer lies in geometry. The moon's orbit is tilted about 5 degrees compared to Earth's orbit around the sun. Only when the three bodies line up exactly a configuration called syzygy does an eclipse take place. With this foundation in mind, let's expand our view. Where else in our solar system can eclipses be seen? If the moon can eclipse the sun from our perspective, then surely Earth can do the same from the moon's perspective. And indeed, it does. When Earth passes in front of the sun, it casts a much larger shadow across the lunar surface. From the moon, Earth appears 4 times larger than the sun, so during such an eclipse, the entire moon can fall within Earth's umbra. To an observer on the lunar surface, this would be a total solar eclipse caused by Earth, but Earth has something the moon lacks: an atmosphere. Sunlight bends through this atmospheric shell, scattering shorter blue wavelengths and allowing only redder light to pass through. As a result, the moon takes on a haunting reddish glow. This is what we on Earth see as a lunar eclipse, when the moon appears blood red in our night sky. Spacecraft have captured these views firsthand. Japan's Kaguya orbiter in 2009 recorded the spectacle from lunar orbit. Apollo astronauts in 1969 even witnessed Earth's shadow enveloping their spacecraft on the journey home. More recently, satellites like DSC-OVR and SDO have captured the moon itself passing in front of Earth and the sun. But the moon isn't alone in crossing the sun. Sometimes entire planets make the journey. Mercury, tiny and fast, frequently transits the sun. Its next crossing after 2019 won't happen again until 2032. Venus, larger and closer, makes a far more dramatic transit. The last pair occurred in 2004 and 2012, and if you miss them, you'll have to wait until 2117. These events remind us that eclipses are not unique to Earth. They are woven into the very fabric of orbital mechanics. Now let's leave Earth behind and travel to our red neighbour Mars. Mars has two moons, Phobos and Deimos. Both are tiny compared to our moon, but they orbit much closer to Mars. Phobos, only about 22 kilometres across, circles the planet at a distance of just 9,000 kilometres, so close that it rises and sets twice each Martian day. Despite its small size, Phobos is close enough to block the sun. And thanks to the Curiosity rover, we've actually seen it happen. In 2019, Curiosity captured video of Phobos passing directly in front of the sun, its irregular outline clearly cutting into the solar disk. The eclipse lasted only about 30 seconds, but the Martian landscape visibly darkened during the event. In another remarkable recording, Curiosity even witnessed Phobos eclipsing Deimos, one moon, passing in front of the other. These observations are more than just visual curiosities. They help scientists refine the moon's orbits and better understand Mars's gravitational environment. From the surface of Mars, eclipses are fleeting but mesmerizing, a reminder that even in alien skies, the cosmic dance of shadow and light continues. If Mars offers a taste, the gas giants deliver a feast. Jupiter, the largest planet in our solar system, is orbited by over 90 moons. 4 of them, Io, Europa, Ganymede and Callisto, are massive enough to cast dramatic shadows on Jupiter's vast cloud tops. Hubble has recorded scenes where multiple shadows glide across the planet simultaneously, each one the size of an entire continent on Earth. Because Io orbits closest, its shadow is the sharpest, while Callisto's more distant orbit produces a broader, blurrier penumbra. Watching these overlapping shadows sweep across Jupiter is like witnessing a cosmic ballet on a planetary stage larger than all the other planets combined. Saturn offers equally stunning displays. Cassini, during its mission, captured countless eclipses as its moons, Titan, Diona, Enceladus, Mimas, and others passed in front of the planet and even across its rings. Every 15 years, Saturn's tilt aligns so perfectly that the moon's shadows fall across the rings themselves, creating a pattern of moving dots and streaks that ripple across the icy bands. From our perspective, these events are mesmerizing. But imagine standing on one of these moons, looking back toward Saturn, watching the enormous rings fade into shadow. It would be one of the most awe-inspiring sights in the solar system. Further out, eclipses grow rarer but no less striking. Voyager 2, during its 1989 flyby of Neptune, captured the planet and its moon Triton aligned in a delicate crescent view. A few days later, Neptune itself occulted Triton from Voyager's perspective, providing a fleeting but unforgettable alignment. Even Pluto, though only a dwarf planet, has gifted us with remarkable imagery. When New Horizons passed by in 2015, it looked back toward Pluto and saw the tiny world silhouetted against the sun. Backlit Pluto's thin atmosphere glowed, revealing layers of haze stretching far above its frozen surface. In that moment, a distant world over 4 billion miles away briefly became a stage for an eclipse that no human eye had ever witnessed before. So far, we've treated eclipses as spectacles of light and shadow, but they are also powerful scientific tools. In 1977, astronomers studying the star SAO 158687 noticed its light dimming as Uranus passed in front, but then to their surprise, the star flickered multiple times before and after the main occultation. This was the discovery of Uranus's rings, hidden until an eclipse revealed them. Today, the same principle allows us to find worlds far beyond our solar system. Telescopes like Kepler monitor the brightness of distant stars. When a star dims at regular intervals, it signals that a planet is transiting in front of it. Using this method, astronomers have discovered thousands of exoplanets, some rocky, some gaseous, and some lying within their stars' habitable zones. And eclipses have guided us for much longer than that. Over 2,000 years ago, the Greek astronomer Aristarchus used the geometry of lunar eclipses to estimate the distance from Earth to the Sun. His calculations, astonishingly, were within a few percent of the modern value, so eclipses are more than cosmic spectacles. They are windows into discovery, allowing us to probe atmospheres, uncover hidden rings, and detect entire new worlds. From the crimson glow of a lunar eclipse to Phobos racing across the Martian sky, to the vast shadow play on Jupiter and Saturn, eclipses remind us that the universe is dynamic, alive, and full of wonder. They are both beautiful and useful fleeting alignments that not only capture our imagination but also expand our understanding of the cosmos. So the next time you see the moon darken the sun or hear of a planet crossing its star hundreds of light years away, remember, you are witnessing the same cosmic dance that plays out across the entire solar system. And as always, if you enjoy exploring the universe with us, don't forget to subscribe and share, because together we'll keep unraveling the mysteries of the cosmos one story at a time. From the crimson glow of a lunar eclipse to the fleeting shadow of Phobos on Mars and the immense ballet of Jupiter's moons, we've seen how eclipses are both cosmic spectacles and powerful scientific tools. They reveal atmospheres, uncover hidden rings, and even point us toward planets orbiting distant stars. Eclipses remind us that shadows don't just hide, they reveal. And in every fleeting alignment, we gain a deeper glimpse into the mechanics of our universe. If you enjoyed this journey, don't forget to subscribe to Cosmic Compass and share it with fellow explorers, because together we'll continue charting the mysteries of the cosmos, one story, one discovery at a time.